All right, section 1.6. So this section and the next section, this one's called two-dimensional figures. Take a wild guess what the next one's called. Three-dimensional figures, okay? But this one, excuse me, I think this one's way more important than the three-dimensional figure one, okay? The three-dimensional, we're not going to really do hardly anything with three-dimensional figures the rest of the year. There might be one little thing in there, but this right here, this one's the important one, okay? Now, I'm not telling you not to pay attention to the next one, but this is really important. This will probably take 2 days, so oh, come on, there we go. So if you want to call this part A, you can call it part A, because I really doubt we'll finish this whole thing today. But I'll give it a good shot. I'll try to get as much done as we possibly can. So I'm going to break this up into 2 homeworks as well. So we're going to have a 1.6a, 1.6b. All right, so keep that in mind. I think that's on your... Oh, I didn't give you a lesson plan, did I? Zion, can you pass this out for me? Just give me the leftovers. Thank you. All right, so take the lesson plan, look over it. Is there a quiz on there this week at all? I can't remember. Yeah, Thursday, is that right? All right, quiz on Thursday if everything goes as planned up to that point. So just look at that, keep that in mind. Please don't leave those lesson plans on the desk or on the floor or in the trash. Keep it with you. The reason I give them to you is so you know what we're going to be doing every day. You know what the homework is. All right, guys in the back, I'm speaking. Thank you. All right, so let's talk about this. First thing we're going to do, you've already talked about it. You learned it when you were a little kid. I mean, I'm talking a little kid. So the first word is circle, all right? And you basically know what a circle is, but we're going to talk about a few things with the circle. So let's draw a circle. I think everybody could have figured that out, that was a circle to begin with. But there's a couple things we want to discuss here. Put a dot right there, and that's pretty important. All right, I'm not going to go over the definition. You're not going to remember it or even care after I'm done. So I just want you to know a few things about the circle. I put a point right, let's start here. The circle is actually this round thing right there, okay? It's the white part. It's not inside here. For instance, like that's a circle, right? Everybody see that? Right? But the stuff inside there is not the circle. What's the actual circle? It's like the outside of it, okay? Yeah, so the part that is in white, okay, that is the actual circle. But we do have, where is this point in reference to this circle? Like if I said that's, if I put a point out here and I put a point in here, what's this point right here? It's in the interior of the circle, right? It's inside the circle, right? This is the actual circle part right here. That line that goes around, that curved line that goes around, that's the actual circle part, right? So this part right here is not the circle. Everybody understand that? All right. So, and if this is the interior, where is this one? Exterior, yeah. So, oops, don't want to get rid of that one. Keep that one. All right, so that's good enough. Now, we're going to get a little more specific about this. This point right here is like dead in the middle of the circle, which means this. It means if I drew a line segment from this point anywhere on the circle, that line segment's going to be the exact same length. All right, so it's not just any random point, like right here. If I drew a point right there, and I drew a line segment from there to there, and then I drew another line segment from here to here, are they different lengths? Yes. Yeah, absolutely. Okay. So that point is just some rando circle, all right? It's nothing special about it. But this point right here is very, very special, because if I drew a line segment from that point anywhere on the circle, these two segments, I'll put a little tick mark on there, those two segments are going to be exactly the same. I could keep doing that forever, couldn't I? From here, anywhere on the circle. What's true about all three of those segments now? They're all equal to each other, okay? So this point, some people say it's in the middle of the circle. I said it. I really shouldn't say it. It's not really a good geometry way to say it. But we say this thing is in the center of the circle. Okay, so that point right there is the center of the circle. It's not too hard, is it? No. All right, that's the center of the circle. Now, we have to label this circle or name the circle. So let's do that. Since it's a point, how do we name a point? What do we always use for a point? Well, I got the dot right there. How do we name it? We don't name it with a dot. We name it with a capital letter. All right, so we'll call it A. Just make it easy. So that would be point A. Everybody see it? And that is the center of the circle. All right, so if I asked you a question, what is the center of this circle? You would just put A. Don't put a dot in front of it. I saw a couple people do that. I can't remember if it was this class or the other class. I graded them all the same time, so I can't remember. But you don't need the dot there to say point A. All you have to have is a capital letter, right? So that's the center of the circle. So if the question was, what is the center of the circle? You would just put capital A. Don't put a lowercase. On the quiz, I took off like the plane. I had a couple people put a capital R for that plane, all right? How do you label a plane? With a lowercase. If it's in the corner, and even the instructions on that quiz even made a lowercase r, didn't it, for that plane? And I still have people putting a capital R in there, all right? Okay, everybody with me? Yeah, I see some people having a hard time. So let's do this. So that particular point, that center, is the same distance. If I drew a line segment from the center to anywhere on that circle, it's going to be exactly the same. So let's talk about that line segment more specifically. So if I started at the center and I went to anywhere on this circle, we'll call that point B. Okay, that length right there is going to be the same no matter where I draw it to. Okay, as long as I start from the center and I draw it to anywhere on the circle, this length is going to be the same. We have a name for this length right there. And you probably studied this before. What is it? What is the name of the thing that goes from the center to a point on the circle? It's the radius. Very good. So it's the radius of the circle. Again, this shouldn't be new to you. You probably already know that. But if you didn't, now you do. So what if I asked you, what is the radius of circle A? I'm not going to write it down. I just said it verbally. What is the radius of circle A? Or name the radius. Let's say it that way. It's better. Name the radius. Is B a radius? B is a point. What kind of AB? What is it? Is it a line? It's a line segment. So what's the symbol for line segment? Just a straight line with no arrows on it, okay? So this right here, what's the question for this? What is the what? Center of the circle. You would just put A. This question says, what is the radius, or name the radius is probably better to say. Name the radius of this circle. You would put line segment AB. Don't just put AB. AB represents the length of the segment. Do I have any idea what the length of that segment is? No, they didn't tell me, right? So don't just say AB. If it says name the segment, you would write line segment AB. Now, this is a subtle difference, but it's more than subtle difference. It's a pretty big difference, I think. What if I told you that the length of that was 5 centimeters? Okay? And then I said, find AB. And that's all I said right there. That was the question. Find AB with no line segment over top of it. What am I asking you to do? Find not just AB, find the measure of, okay, or the length of, either way. Okay, find the length of AB. What would you say? 5 centimeters, and that's your answer. Everybody see the difference? So if I ask you to name the radius, you would put line segment AB. If I said find AB, that means find the length of line segment AB. They tell it to you right there. It's not hard to figure out, and you just write it down, 5 centimeters. We okay? All right. You could, if you wanted to, say the radius is BA, line segment BA. I'm going to put or. But we don't usually say that. We usually start at the center. Do you have to start at the center? No, not necessarily, but it's a lot better. So this one that's circled right there, that's the best choice. This is not wrong, but if I ask you for the radius, start at the center. It just makes more sense, okay? Everybody hear that? Did you write that down? All right? So this is the better way. This is better. This is still okay. I'll put a little okay next to it. It's okay, but it's not better. This one's better, starting at A and going to B. All right, let's see. Oh, we got to talk about one more thing, then we'll go to something else that's not a circle. I can name this circle. So right here, I just named the center of the circle. I just put an A. But what if it said to name the circle? And it's all this stuff is written like this, okay? Not every circle is going to be named this, just the one that I named. We got to name the circle. So we always name the circle by the center of the circle. So what's the center of this circle? It's point A, right? So we name it circle A, but we don't write the word circle. We got a symbol for it, just like we had a symbol for line, for ray, for line segment, for angle. Abdul, you getting all this? Come on, wake up. All right, let's pay attention. I don't care. I don't want your eyes closed, and I don't want your head down. I want you looking up. All right? So it says, name the circle. Here's the symbol for a circle. Well, we put a circle, and then you put a little dot in the middle. That right there, okay, is what we use to represent a circle. So how would I name the circle? Circle what? Circle A, because that's that's the center of the circle. So we call it circle A. All right? That's some really basic foundational stuff about a circle. We're actually going to have a chapter later on in the book. It's a ways off. It's probably towards the end of the year. I think it's chapter 8, if I remember right. Don't know why I remember that, but I think it's chapter 8. We're going to have a whole entire chapter just on circles. A whole chapter just on circles. You're like, what in the world could you even know about circles that would fill a whole entire chapter? Well, there's a lot to know. But right now, we're just learning some foundational basic stuff. This is all we need to know. Well, it's basically all we need to know about circles right now. Yes, Malik? Is this review? Everything that I do has a possibility of being on the quiz. Every single thing that I ever talk about in here has a possibility of being on a quiz. All right? So you should always write down everything that I write down, thinking, hey, I may see this on a quiz or a test or the homework. All right? But this right here, it's just getting us to understand what a circle is. All right, I think I covered everything with circles. Let's do another word. Again, these are what? Two-dimensional figures. It means they don't come off the page. They're just flat. That's what it means just by two-dimensional. It's got width and it's got height. That's all it has. It doesn't come off the screen or it doesn't come off your paper. Everybody with me on that? It's just two dimensions. That's why they call it two-dimensional figures. So these are just all things that are flat that we can draw on a piece of paper or my computer program. All right, here's another word. This is word we're going to use a ton. Okay, it's called a polygon. It's basically made up of two words. It's made up of the word poly, which means many. And that word gon right there is talking about the angles. All right, so a polygon is something with many angles. Now, the thing that has to be true about a polygon, it's got to be closed, which means you can't have any openings in it, all right? And it consists only of line segments, all right? So you can only have line segments. So let's use my polygon tool right here. There you go. There's a nice polygon. Okay, it's closed. What does that mean it's closed? It means there's no gaps in here, okay? All the line segments come together at the endpoints. Guys ready? So all the line segments come together at a point, okay? There's no opening. It does, they always touch each other. So here's a line segment, here's a line segment, and they come together right here. Look, all along this thing. Does one extend further out than the other? Nope. At each endpoint of the segments, they always touch. They always come together, all right? So that basically is a polygon. There's a couple things about the polygon that we need to discuss. All right, let's talk about that point where they come together. We've actually used this word already. If you look at this, look, a line segment here, a line segment here. What does it form? It forms a what? An angle. Good. All right. And what's always at that point where they touch each other, they intersect each other? What do we call that? Well, they do intersect, but what do we call? We have a special name for it. It's not just, no, it's not the corner. We've never said corner. Starts with a V. Vertex. Okay. We forget so quickly. All right, so that's a vertex. All right, and that's a vertex of my polygon. In this particular one, did I tell you what the plural of vertex is? So if you have more than one vertex, they are called vertices. That's the plural. I'll put a PL right there for plural. Okay? So if I have more than one vertex, we don't call them vertexes. We call them what? Vertices. Very good. All right. How many vertices does this particular polygon have? 6. 1, 2, 3, 4, 5, 6. Yeah. How many line segments do we have here? We got 6. So we have just as many angles, right? Remember the vertex makes an angle right here? Do you see that? We have just as many angles as we have vertices as we have line segments. Well, the line segments have a special name as well, and we call these the sides of the polygon. All right? So every one of these line segments is called a side. All right? So we got a vertex, we got a side, and we got angles in here as well. Is every polygon got 6 sides? No. Okay, they could have a bunch of sides. What's the least number of sides that a polygon can have? 4? 3? Can you have 2? I'm asking you. Remember, a polygon's got to be closed figures. So can you have 2? You can't have 2. Why not? Why can't you have 2? They won't connect. That's right. And if they do connect, it just makes a line, doesn't it? Okay? It's not closed. There's nothing inside of there. Everybody see that? All right? So 3 is correct. All right? 3 is the smallest number of sides that you can have. What's the biggest number of sides that you could have? 10? You can only have 10 sides? You can have an infinite. Very good. That's what I was looking for. You can have an infinite number of sides, okay? That'd be pretty crazy, but you could if you wanted to, all right? Again, I said it already. Can you only have 6 sides since I put 6 sides right here? No, all right? Let me talk about this, a couple other words. This one right here, I drew, actually, I don't think I drew it. I don't think I hit the shift button, so let me do that. Watch this. So with this program, I can actually change the number of sides. Right now it says 6. Do you see that? Let's change it to 8. All right. There we go. Now that particular one right there, look how many sides I got. 1, 2, 3, 4, 5, 6, 7, 8. That means I got how many vertices? How many sides do I have? How many angles do I have? Very good. All right. That's a special name. We're going to talk about the special names in a second. But I want you to see something. The way I drew that, and let's draw a couple more. Let's draw one with 3. All right. So what do you think that's called? Right. And let's do another one. We already did 6. Let's do another one. Let's do like 5. Okay. But there's something special about these. Okay. The way the computer program makes them a certain way. I could change it a little bit, but I just wanted to keep it like this because this is what I wanted to talk about. Okay. So here we go. If you can draw those, great. If you can't, it's not that big of a deal. I want you to see something. Look at every side on this 8-sided figure, this 8-sided polygon. What do you think might be true about the length of every one of these sides right here? They're all the same. Exactly right. So what could I put on there to show that they're all the same? A little what? What do you call that thing? No. It's a something mark. What's the word? No, we've talked about this before. Does that look like a question mark? Yeah, all the sides are the same. So what is that little mark? It's a tick mark. It's a tick mark. So if I did this and all the sides are exactly the same, and they are, just because of the computer program, the way that it drew it, all the sides are exactly the same. So if all the sides are exactly the same, or I'll say this, if all the sides are equal, then here's the name. Then it's, I'm going to put it in caps. It's equilateral. E-Q-U-I, then lateral. L-A-T-E-R-A-L. All right, spell it right, please. All right, equilateral. E-Q-U-I. It's not equa with an A. It's an I. E-Q-U-I. Then lateral. Everybody should be able to spell lateral. L-A-T-E-R-A-L. Lateral means sides. Okay, if you I say this all the time. I teach this. If you ever played a sport or something, they usually, especially in basketball, even football, I guess they can do this. But in basketball, they do this drill all the time. Where they hold the ball, the coach will have the whistle, right? And you guys get in a defensive stance. Anybody play basketball before? And then they go like this, right? They put the ball to one side, blow the whistle, and you move side to side, okay? So it's a common drill. They call it, what do they call that drill? They call it the lateral drill, all right? Because you're going what? Side what? To side. Guys, let's stop. Ben, you need to leave? All right, control yourself, please. So from side to side, okay, that's why they call it equilateral. What do you think the equa comes from? Equal. So this means equal what? What's lateral? I just said it. What does lateral mean? Sides. Okay, it just means sides. Just means side. Not side to side, but it just means sides. So this means equal what? Sides, right? In the word, it basically tells you what it means, doesn't it? All right, it's got the equal and it's got the side, and that means if all the sides are equal, then that thing's equilateral. Same thing with this. Watch. If all three of these sides were equal, then this is what? Equilateral. If all 5 of these sides were equal to each other, then this would be called what? Equilateral. Very good. Right? Here's another word that we're going to do. Again, the way that I drew this on this program, or the way the program drew it, it made all the angles exactly the same. All right, so I'm going to put them all. I'm not going to do that for every single one of these. We'll do it for this one. All right. So if all the angles are equal to each other, okay, if all the angles are equal, then we call it, I should put that there. Then it's equa again, but it's not lateral. It's all the angles that are equal. So we call it equiangular. All right? Then we call it equiangular. This one's really easy to see. You see the word equa in there. That means they're equal. What other word do you see in there? Angle. Right. Angular. You see the word angle in there. So if all the angles are equal to each other, then it's equiangular. Now, all of these, now just because it's equiangular doesn't mean that it's equilateral. There are situations, I don't know if I can draw it or not, but there are situations where all the sides are equal, but all the angles are not equal. All right? There's situations where all the angles are equal, but all the sides are not equal to each other. All right? Everybody got that? So sometimes it's only equilateral. Sometimes it's only equiangular. Again, I can't really draw that too well with all of these, but that's what we have. Penny? I'm trying to figure out how to draw. Well, if you drew a triangle that had all 3 sides equal to each other, all the angles are automatically going to be equal to each other. But you can draw some other figures that have different sides but have the same angles, and vice versa. All right? But let's just talk about this for right now. What if you had both? What if you had both? Okay? The sides and the angles equal to each other. Then we give it a different name. So this thing right here has got both, doesn't it? Actually, all 3 of these. All the sides are equal, all the angles are equal. If both of those things are true about that picture, okay, we call that then it's a regular polygon. And I probably should have put the word polygon here. Equilateral polygon and equiangular polygon. So if both things are true, okay, if the angles are equal to each other and the sides are equal to each other in that one particular picture, then we call it a regular polygon. That's going to come into play again in another chapter. I keep saying this because this is not the only time we're going to learn this. We just learned it for this quiz and test, and then we're done with it. We are going to be using this stuff throughout the rest of the year, okay, this regular polygon especially, all right, and even equilateral and equiangular, okay? It's really important that you know these words, okay? I'm not just telling you this. We will absolutely use this, all right? So there we go. All right, I drew 3 different shapes here. This got 8 sides, got 3 sides, 5 sides. We did one with 6 sides, all right? A lot of these, especially the smaller number of sides, have special names. So we are going to write down those names, and you're going to have to memorize these words, all right? You're going to have to know them, because on a quiz and a test, I'm going to say, what is the name of a 6-sided polygon? And you're going to have to tell me what the name of that is, okay? No. That's almost my whole class. All right, you guys need to watch the video because I'm going to keep teaching. All right, so here we go. What I'm going to do, I'm going to give some names, and you really need to write this down. All right, I'm going to give you how many sides there are, and I want you to name the polygon. Everybody good? All right, so the first one, I bet you everybody in here, we've already actually said it. If you have a 3-sided polygon, now, it doesn't matter if all the sides are equal, all the angles are equal, or anything like that, okay? If you have any polygon that's got 3 sides, it can be some crazy looking, I'm not going to do this for every one of these, but watch. It could be like this, it could be like that, okay? It could be something like that, all right? That's definitely not equilateral, is it? It's not equiangular either, all right? But it does have how many sides? It's got 3 sides, okay? We could do all kinds of different triangles. Oh, I just gave it away. So what do we call something with 3 sides? It's a triangle. All right, that's easy. All right, now, 4 sides. A lot of people would think it's a square. A lot of people would say rectangle. And a rectangle is a 4-sided figure. A square is a 4-sided figure. But is every 4-sided figure a square? For instance, here I'll do it with this one. Watch, what if I had this? Is that a square? Is that a rectangle? How many sides does it have? So we need a name, don't we? We need a general name for 4 sides. A square and a rectangle are specific 4-sided figures. All right? And we will talk about that. All right? I know exactly when and where we're going to talk about it. All right? But not right now. So this is called a quadrilateral. Have you ever heard that word? Quad, R-I, then lateral. There's that word again. Lateral meaning what? We just talked about it like 5 minutes ago. What's lateral mean? Sides. Okay, what does the prefix quad mean? Okay, this is going to test your knowledge of your prefixes. If you know your prefixes, this is going to be really, really easy. Okay, what is the prefix for triangle? It's tri, which means what? 3. Okay, make sense? So this means 3 angles. This means 4 what? Sides. So if it has 4 sides, it's also going to have 4 angles, all right? But we call it a quadrilateral. Quadrilateral, that's how I would say it. All right. Now we're really getting to the ones, they're all going to kind of sound the same except for the prefix, all right? The prefix is just going to be different. The prefix for 5 is penta, P-E-N-T-A. And then since it's a polygon, what do you think we're going to call it? A pentagon. Very good. There's even a big building, huge building in Washington, D.C. It's called the Pentagon. You ever hear of that? Okay, why do they call it the Pentagon? Because it's shaped with 5 sides, all right? So look it up. It was really famous in 01, 2001. Why was it famous in 2001? You guys weren't even born yet. But what was really famous about the Pentagon in 2001 on September 11th, 2001? Yeah, the plane hit it, right. I don't know how many. Did one or two? I think maybe just one. Yeah, so one plane hit the Pentagon. There were quite a few people died in that. But people always think in New York, with 9/11. But people died at the Pentagon as well. And, it was just as bad for the people who died. So anyway, that's Pentagon. So what if you had 6 sides? Anybody know what the prefix for 6 is? Maybe not. I'll show it to you. It's hexagon. Hexagon. All right? You got to know these words. You got to be able to associate them with how many sides you have. Now, obviously, if there's this many sides, how many angles will there also be? Just the same amount, okay? So if there's 3 sides, there's 3 angles. 4 sides, 4 angles, and so on. Everybody got that? All right. 7's kind of a weird one. 7, I think the book uses heptagon. Hepta. You don't really see that very often. We don't do a lot with that. We do quite a bit with triangle, quad. In fact, triangle, I believe we have a whole entire chapter just on triangles. Isn't that crazy? Just a simple little 3-sided figure. We got a whole entire chapter on triangles. That's crazy. In fact, there's actually full courses, a whole entire math course, basically just about triangles. It's called trigonometry. You ever hear of trigonometry? All right. That deals with triangles. A whole course on it. It's amazing what people come up with. All right, keep going. 8. It's an octagon. Where do you probably see an octagon every single day of your life if you go outside? A stop sign. That's right. Okay. And a stop sign is not just any old octagon. What do you think it is? Like right here. That's a stop sign right there. Right? Stop. All right. It's equilateral and equiangular, which means it's a regular polygon. So this is a regular octagon. A stop sign is a regular octagon. All right, let's keep going. 9's a weird one. You don't usually hear this very often, but they call it a nonagon. I guess non is pretty close to 9. I don't know why they just don't call it a nineagon, but they call it a nonagon. Again, we don't use that too often. This one we use quite a bit, and it's called a decagon. So 10 sides is a decagon. That should make sense. You should know that prefix. Where do you know that prefix deca from? It means 10. It means 10. So talking about time. What? Decade. Very good. Okay, so a decade is 10 years. A decagon is 10 sides. All right? This one, unless I looked at this book, I probably would have never known this one. So I kind of doubt that you know this one. But it's called 11 sides. It's called a hendecagon. Yep. I told you I was a weird one. Unless I taught this, right, and looked at this lesson, I bet you if you would have asked me an hour before this class, I probably wouldn't even remember what it was, all right? What's that? 20? I should know 20. It's not tetra. We do that with the 3-dimensional ones. I forget. It's some kind of crazy name. But we're going to stop at 12 on this. Why do you think it's all right to talk when I'm trying to teach? It's like the 4th time I had to say something to you guys. I can't wait till the marking period's over. Then I'm going to split you guys as far as I possibly get you. All right, here we go. Last one. Dodecagon. Decagon. All right. So these are weird ones. Okay, these are ones you're going to have to study. Okay, I would have to myself. All right, if I was going to give a quiz to myself, I might not remember a hendecagon or I've done dodecagon a lot, so I probably would remember that one. But hendecagon, that's the one that I probably wouldn't remember. But That's what it is. So remember it. And that's basically the end of the special names. We're not going to go on forever, right? It'd just be crazy to give every single number its own name. We'll stop at 12, but these are ones that you have to know. I'll tell you the ones that we're really going to deal with a lot, all right? Triangle, obviously. We're going to do a ton of stuff with quadrilaterals. We'll do a little bit with pentagons, hexagons. We don't talk about heptagons too much. We do talk about octagon a lot. We talk about decagon a lot. So those are the ones right there that we're going to deal with more often than the other ones. All right, but right now we're just learning the names. That's all we're trying to do is just learn the names of these. Again, do all the sides have to be equal to name it this? No. Do all the angles have to be equal? No. All right, we just want to know what they are. All righty. Let's talk about naming a polygon. We already found out what the names of different sides are, but now what we're going to do is we're going to name the polygon. All right. So let's just do this. I'll use this thing right here. Oops. I'm going to go 3. Oops. What's going on? There we go. There we go. Everybody watching? Now, if you had a triangle, I'm getting a little ahead of myself right now, but that's okay. Let's deal with this anyway. So A, B, C. All right. This is one that's a little more special than everything else, a triangle. So if I wanted to name this triangle, I'm going to put a triangle symbol. That's my symbol for triangle. Looks just like a triangle. Okay, makes sense. And then I'll call it ABC. Did I have to start with A? Nope, doesn't matter. Okay, just like a line, it doesn't matter what order we go in. Just start with one and then do the next one, then the next one. Okay, so that'd be triangle ABC. What's another possible name I could name this triangle? BCA. Sure hope you don't go out for the basketball team. Goodness gracious. That was a layup. All right, you could call it what? B what? BAC. You can go CAB. Any combination of the three, right? You can call the triangle, okay? What if you get more than 3 sides, though? Okay, we don't get really specific with it. What we're going to do is we're just going to name it polygon, and then you're going to start at any point and go around in a certain direction. So, for instance, let's go 5 sides. What do we call a 5-sided figure? Pentagon. Now again, this doesn't have to be, see look, I can make it go out like this, right? So it's not necessarily a regular pentagon. We'll just make it look weird like that, a little stubby looking pentagon, right? And let's call this A, B, C, D, and E. All right, everybody good? So if I wanted to name it, if I wanted to name this pentagon, you could, I guess, use the word pentagon since there's 5 sides. But you could just go real general and call it polygon. And then how would we name this? Yep, you could call it A, B, C, D, E if you wanted to. It doesn't have to be a regular. No, it's not regular because look, that side right there and this side right here are definitely not the same angles or sides. This angle and this angle are definitely not the same. So it's not regular. It's not equilateral. It's just a regular old polygon. So it doesn't matter what letter you start with. I mean, normally we would probably start with A in this situation. So let's just call it A. Now, if you go from A, you could go AE, right? Or you could go A what? B. But depending on which direction you go, you got to keep going in that direction. You can't just skip around to random points. Everybody hear me on that? So you're not going to call this AD anything else. You got it? So it's either AE or AB. All right, so it's AB what? C, D, E. What if I didn't want to start with A? I wanted to be different, right? I want to be a rebel, and I didn't want to start at A. Let's start at, I don't know, C. If I started at C, I could go one of 2 directions. Which way? Yep, I could go C, B, but then what do I have to do? I got to go around the horn. You see that? So if I started at C, I would go to B, then what? A, E, D. There's so many different possibilities of naming this particular polygon, all right? I think the easiest way is going in alphabetical order, if it's written in alphabetical order, all right, and then there you go. So we're going to talk a little more tomorrow about triangles more specifically, and some other things as well. So everybody's leaving. Did I dismiss you? I didn't. Everybody just gets up. This is 1-6A, and it's pages 35 and 36. Do as many of these as you can. I gave you a paper on it. I handed you a piece of paper with these exact things on there. All right, you don't have to take a picture of it. I gave it to you. All right, there's your work. That's basically just for the people watching it on YouTube. I already gave you a piece of paper today with the lesson plans on it. It's got that in there. It's got that on there exactly. Actually, I lied a little bit. On the lesson plans, I just gave you 13 to 20. Okay? So 13 to 20, that's all you got to do.